Assalamualaikum everyone and a very good day to all. In this video we shall learn about the basic laws in electric circuit. Previously in chapter 1 we already introduced the basic concepts such as current, voltage and power in electric circuit. To actually determine the values of these variables in a given circuit, we require some understanding on the fundamental laws that governs the electric circuit. So for chapter 2, I will divide it into two parts, and this video will cover the ideal sources in series and parallel, resistance, Ohm's law, and also definitions of open circuit, short circuit, conductance, and also branches, nodes, and loops. Here is the table of contents for you to navigate through this video. So let's go into ideal voltage source. Ideal voltage source connected in series can be added, and ideal voltage sources cannot be connected in parallel. Remember that ideal voltage source will guarantee the voltage between two terminals at the specified potential. While it may not be the best practice for circuit analysis, ideal voltage sources can be connected in parallel provided they are of the same voltage value. Therefore, connecting together ideal voltage sources that have different voltage sources are not allowed. And also short-circuited by an external closed loop or branch is also not allowed. Series voltage sources are basically series connected sources with their polarities connected, so that the plus terminal of one is connected to the negative terminal of the next, allowing current to flow in the same direction. And this will have the sources add together, and the series opposing voltage sources when are in series connected sources which have their polarities connected, so that the plus terminal or the negative terminal are connected together as shown here. The net result is that the voltages are subtracted from each other. Next, let's go to ideal current source. Ideal current source connected in parallel can be added, and ideal current source cannot be connected in series. Let's recall that ideal current is a guarantee the current flowing through the source is at the specified value, and current entering a circuit must be equal to the current leaving the circuit. Okay, connecting two or more current sources in parallel is equivalent to one current source whose total current output is given as the algebraic addition of the individual source currents, and current sources are not allowed to be connected together in series, either of the same value or ones with different values. Then series connected current sources add an unknown factor into circuit analysis, which is not good. Also, another reason why series connected sources, current sources are not allowed for circuit analysis technique is that they may not supply the same current in the same direction. And also by right series opposing currents, like I showed in the voltage source, ideal voltage source, do not exist for ideal current sources. Next, let's have a look at resistance. Materials in general have a characteristic behavior of resisting the flow of electric charge. This physical property or ability to resist current is known as resistance and is represented by the symbol capital R. The resistance of any material with a uniform cross-sectional area A depends on the area A and its length L, as shown in this figure. We can represent resistance as measured in the lab in a mathematical form, such as R equals to rho L over A, where rho is known as the resistivity of the material in ohms meters. Good conductors such as copper and aluminium have low resistivities, while insulators such as mica and paper have high resistivities. The circuit element used to model current resisting behavior of a material is the resistor. For the purpose of constructing circuits, resistors are usually made from metallic alloys and carbon compounds. The circuit symbol for the resistor is shown here. and where capital R stands for the resistance of the resistor. And also the resistor is the simplest passive element. Okay, next let's go to Ohm's law. In 1826, a German physicist named George Simon Ohm, he experimentally determined the most basic law relating voltage and current. Ohm's work was initially denied by critics, but later on was credited with finding the relationship between current and voltage for a resistor. This relationship is known as Ohm's law to honor him. Okay, Ohm's law states that the voltage V across a resistor is directly proportional to the current I flowing through the resistor. That is, V is proportional to I. Ohm defined the constant of proportionality for a resistor to be the resistance R. The resistance is a material property which can change if the internal or external condition of the element are altered. For example, if there are changes in the temperature. Thus, the previous equation becomes V equals to IR, which is the mathematical form of Ohm's law. R in this equation is measured in the unit of ohms, designated with this symbol, ohms. Okay. Thus, the resistance R of an element denotes its ability to resist the flow of electric current. Okay. To apply the Ohm's law as stated before, we must pay careful attention to the current direction and voltage polarity. The direction of current and the polarity of voltage must conform with the passive sign convention. I hope you still remember that, as shown here in this figure. So this implies that current flows from a higher potential to a lower potential in order for V equals to IR. If the current flows from lower potential to a higher potential, then it will be V equals to minus IR. If we look at the value of R with its two extreme possible, meaning that it can range from 0 to infinity, so there will be two different scenarios that will happen. Okay, an element with R equals to 0 is called a short circuit, as shown in this figure. And for a short circuit, V equals to IR equals to 0. And this shows that the voltage is 0, but the current could be anything. In practice, a short circuit is usually a connecting wire assumed to be a perfect conductor. Thus, a short circuit is a circuit element with resistance approaching 0. Similarly, an element with R equals to infinity is known as an open circuit, as shown here. For an open circuit, I equals to limit from R towards infinity, V over R will become 0. This indicates that the current is 0, even though the voltage could be anything. Thus, an open circuit is a circuit element with resistance approaching infinity. Here is a table of summary to compare between short circuit and open circuit with the different two extreme value of R, and also what will happen in short circuit. Basically, the ideal voltage source with V equals to 0 is equivalent to a short circuit, whereas in open circuit, it is often represented by a wire with an open connection. For short circuit, we cannot connect voltage source to a short circuit, and for open circuit, we cannot connect current source to an open circuit. A resistor is either fixed or variable. Most resistors are of the fixed type, meaning their resistance remains constant. The two types of fixed resistors are the wire wound and the composition or carbon film type. Okay, as shown in this figure. The composition resistors are used when large resistance is needed. The circuit symbol is shown here in this figure, where it is for fixed resistor. We also have a variable resistor with adjustable resistance. The symbol for a variable resistor is as I show here. And then we also have another common variable resistor, which is known as a potentiometer, or pot for short. And the symbol shown here. All right. And the pot is a three-terminal element with a sliding contact of wiper. By sliding the wiper, the resistance between the wiper terminal and the fixed terminals will vary. Okay, like fixed resistors, variable resistors can be either wire wound or composition type as shown here. Although resistors like I have shown you are used in circuit designs mostly, today most circuit components including resistors are either surface mounted or integrated like so. It should be pointed out that not all resistors obey Ohm's law. A resistor that obeys Ohm's law is known as a linear resistor. It has a constant resistance and its current voltage characteristic, as you can see here, where it is a straight line passing through the origin, and you can find the slope, which is it will be equal to the resistance of the element. Another type of resistor is the non-linear, and this type of resistor does not obey Ohm's law. Its resistance varies with current, and its current voltage characteristic is typically as shown here. It is not linear. Some of the examples of devices with non-linear resistance are the light bulb and the diode. Although all practical resistors may exhibit nonlinear behavior under certain conditions, we will assume in this course that all elements actually designated as resistors are linear. A useful quantity in circuit analysis is the reciprocal of resistance, known as conductance, and denoted by capital G. The conductance is a measure of how well an element will conduct electric circuit. So the unit of conductance is mho, which is ohm spelled backward, or Siemens. Okay, so the reciprocal ohm with symbol inverted omega. So in other words, conductance is the ability of an element to conduct electric current. And the power dissipated by a resistor can be expressed in the terms of R. We should take note two things. The power dissipated in a resistor is a nonlinear function of either current or voltage. Since R and G, since resistance and conductance are positive quantities, the power dissipated in a resistor is always positive. Thus, a resistor always absorbs power from the circuit. And this confirms the idea that resistor is a passive element which is incapable of generating energy. Let's see the first example. An electric iron draws 2 ampere at 120 volt. So we want to find its resistance. So V equals to IR, and you need to find R. So from Ohm's law, we can get R equals to V over I. So substitute 120 for V and 2 for current, and you'll get 60 ohm. So let's see another example. In the circuit shown in figure above, calculate the current I, the conductance G, and the power P. So we have 30 volt voltage source and also 5 kilo ohm resistors. So the voltage across the resistor is the same as the source voltage because the resistor and voltage source are connected to the same pair of terminals. Hence, the current can be calculated as I equals to V over R. Substitute V with 30 and R with 5 kilo ohms, and after you divide, you will get 6 milliampere. The conductance is basically G equals to 1 over R. So since you already know the R, you can just invert that and you get 0.2 millisiemens. And finally, the power we can calculate in various ways. Okay, we can calculate using P equals to VI, or P equals to I square R, or P equals to V squared G, the conductance. And all of them will give us the same answers. Just substitute the values that we already got from the previous calculation. Since the elements of an electric circuit can be interconnected in several ways, we need to understand some basic concepts of network topology. To differentiate between a circuit and a network, we may regard a network as an interconnection of elements or devices, whereas a circuit is a network providing one or more closed paths. For this course, networks and circuits will be used interchangeably. In network topology, we study the properties relating to the placement of elements in the network and the geometric configuration of the network. Such elements include branches, nodes, and loops. A branch represents a single element such as a voltage source or a resistor. In other words, a branch represents any two-terminal element. In this figure here, we can see that there are 5 branches, namely the 10 volt voltage source, and we have 2 ampere current source and the 3 resistors. Okay, next we go to a node. A node is the point of connection between 2 or more branches. A node is usually indicated by a dot in a circuit. If a short circuit, meaning that a connecting wire connects 2 nodes, the 2 nodes constitute as a single node. The circuit here in this figure has, can you count how many nodes they have? It's actually there already. It has A, B, and C, which is 3 nodes altogether. Notice that the 3 points that form node B are connected by perfectly conducting wires and therefore constitute a single point. The same is true for the 4 points forming node C. We can demonstrate that the figure in this figure has only 3 nodes by redrawing it again. Alright, these 2 circuits are actually identical. However, for the sake of clarity, nodes B and C are spread out with the perfect conductors, as you can see here. Okay, let's go to loop. A loop is any closed path in a circuit. A loop is a closed path formed by starting at a node, passing through a set of nodes, and returning to the starting node without passing through any node more than once. Okay, so a loop is said to be independent if it contains at least one branch which is not a part of any other independent loop. So that's the definition of a loop. Independent loops or paths result in independent sets of equations. So if you have 3 variables, then you will need 3 different loops, and so on. It is possible to form an independent set of loops where one of the loops does not contain such a branch. For example, here you can see that we have loop 1, ABCA, okay, with the 2 ohm resistor as independent. A second loop with a 3 ohm resistor and the current source is independent. And the third loop could be the one with the 2 ohm resistor in parallel with the 3 ohm resistor. This does form an independent set of loops. When choosing the loops in the circuit, you need enough loops so that each component is covered once without repeating loops, as it would be redundant. A network with P branches, N nodes, and L independent loops will satisfy the fundamental theorem of network topology, which is P equals to L plus N minus 1. 2 or more elements are in series if they exclusively share a single node and consequently carry the same current. 2 or more elements are in parallel if they are connected to the same 2 nodes and consequently have the same voltage across them. Elements are in series when they are chain connected or connected sequentially end to end. For example, two elements are in series if they share one common node and no other element is connected to that common node. So elements in parallel are connected to the same pair of terminals. Okay, so in series, common node, and in parallel, common pair of terminals. Elements may be connected in a way that they are neither in series nor in parallel. Like for example, in the circuit shown here, the voltage source and the 5 ohm resistor are in series because the same current will flow through them. The 2 ohm resistor and the 3 ohm resistor and the current source are in parallel because they are connected to the same two nodes, which is node B and C, and consequently have the same voltage across them. The 5 ohm and 2 ohm resistors are neither in series nor in parallel with each other. Before I conclude this video with the last example, let's just quickly recap with some of the terms that we already learned in this video, but also there are a couple more terms that I need to inform you. Okay, so a loop is a closed path formed by starting at a node, passing through a set of nodes, and returning to the starting node without passing through any node more than once. Okay, so it will go through all these set of nodes and it will return to the initial node, and any of the nodes that it passes through, it has to be only once. It cannot be more than once. Okay, but in a loop, other paths can be included inside. So it is not very specific closed path kind of loop. But this is different with mesh. Okay, so mesh is a closed path in a circuit with no other path inside it. In other words, a loop with no other loops inside it. Okay, so that's mesh. Okay, so what is independent loop? Independent loop is when there is at least one branch which is not a part of any other independent loop within the independent loop. Okay. I hope you are not confused with the so many independent words. Okay, so like for example, if you have for example, you have a loop that does not include the 4 ohms resistor there, then any other loop that has that 4 ohms can be considered as independent loop. Okay, a node is the point of connection between two or more branches, may include a portion of the circuit, which is more than a single point. Okay, and essential node is the point of connection between 3 or more branches. So it needs to be at least 3 or more branches. Okay, so as you can see in the previous example, we have 3 branches in one node and also 4 branches. Okay. Let's look at the final example in this video. Determine the number of branches and nodes in the circuit shown in figure above. Identify which elements are in series and which are in parallel. Okay, so you can see that there are 4 elements in the circuit. Therefore, the circuit has 4 branches, which is the 10-volt voltage source. We have the 5 ohms resistor and 6 ohm resistor, and also the 2 ampere current source for the elements, meaning that there are 4 branches. And the circuit has 3 nodes as identified in this figure 2 and 3. And the 5 ohm resistor is in series with the 10-volt voltage source because the same current would flow in both. And the 6 ohm is in parallel with the 2 ampere current source because both are connected to the same nodes 2 and 3. If you have any questions or comments, please let me know. Thank you and see you on the next video.